Good morning, everyone. Everybody can hear me, right? Right, good. So today we are going to talk about three things. We have two sessions. One is to talk about the data, where we will talk about how to describe your data, what is inferential statistics and analysis, and the important thing that you will be doing a lot is this. You have a two group of data, and then you will perform some tests to find whether they are different or same, or if there are any relationship. This is something that you will be doing a lot, right? Before I go, I should actually explain who am I. So my name is Nikesh Bajaj. I worked at Imperial as a postdoc, and now I am lecturer at Queen Mary University of London. So that's a very simple intro, right? Okay, so next session would be on SPSS. You might have different softwares, but SPSS is widely used, so that's why we are choosing SPSS. With Imperial, you have access to SPSS, and once you go out of the university, you will easily find SPSS available for you for your doing any research. So that's why we have chosen that. It's very simple to use, and we will do everything that we are going to talk about today in SPSS in next session. Okay. All right. So describe your data. So first thing that you do when you do conduct any experiment, or you have a data, first thing that you have is to describe it. Doesn't matter what it is, what did you do for the experiment. The first thing that you do always is to describe what kind of data that you have and everything about it. So we will talk about these things in this session. So first, let's say that you have these 9 number, height of 9 people in a group. How would you describe it? If anybody asks you, like, you have this number, you collect it for some particular experiment, how would you describe this?
The number of samples is 9, and then it range from 116
Mm-hmm.
up to 171,
Mm-hmm.
and then the mean and median would be also 9.
Okay, so that's one of the way. What he said, that we will say that okay, the number of samples are 9, which is n equals to 9, and you will hear this term very much a lot, like n. What is your n? How many numbers of sample you have? So right now we are writing capital N, but some people write a small n. Capital N is for population, small n for sample, but it's okay. It's still not a problem, right? So one of the describing what he said is that we'll say, okay, there are 9 samples, there is a minimum is this, maximum is this, and we will talk about what is a mean and median, right? That's one of the good way to do it. Or if you have just 9 number, give them all 9 number. They can see themselves, right? This is a 9 number. What happens when you have 100? But now his strategy works very well, because he is still talking about minimum, maximum, mean, mode, everything, right? So for 100, you can't actually give them the all 100 number, and you might have a case where you have 2000, but you want to describe it, right? So one thing is just you plot them, right? You can plot all the 100 numbers, and almost everything is visible here. What's minimum, what's maximum, where is something like mean here, something like that, right? Other plot is histogram. You can actually plot histogram, which gives you much more detail in a much concise way. So histogram is every number, how many times it occurs in your data. So this bar is saying that this value occurs only once, this is occur 5, and something like that, right? So it tells you the distribution of the data also, that which value is too much, which is very small. Some value are very rare, but you can also see what is minimum, maximum. You can see something, this is the majority of the value, and you can see where the data lies on a one scale. So it is also one of the very good way to represent your data. We'll come back to histogram a lot, because this is very easy to do, and it almost tell you a lot about the data. So describing a data, we go for average. And we are not saying average is like what is it a mean or what, but average tells you center tendency of data. That means where is the center of the mass, or where is the center of the data, where is the most of the values are. So that's average, but average is a general term. It doesn't say it's mean, it can be median, it can be mode. So average is just a general term. Another attribute that you talk about your data is variability. Like you can say what is minimum maximum, you can say what is standard deviation, interquartile range and percentile, lot of other things. So they say that how spread it is, that you can, two data can have same mean but they can have a different spread, right? So talking about the spread will also tells you something. And third thing is just some nice plots which show your data very well. All right, this is one of the example where nicely plotted height of men born by the year like in 1996, and it's by country wise. So you can see somebody plotted the height of man entire world, and this small figure tells you a lot. You can see that people in this range are taller, most of the Asians are shorter, and these are taller, something like that, right? So it's a very nice figure which tells you a lot of things. So figures are, and visualization is very, very important. It can tell more than what you can write, but of course you have to write, but you can describe it also very well. So before we go into the describing the average and spread, we should talk about what kind of data that you will have, right? Usually you will have different kind of data, and we will see what to do with them. So there are two kind of data type or variable. One is called the numerical, another is categorical. Numerical have inside it's quantitative, which you quantify anything. For example, heart rate, blood sugar, time, and this is one of the example here. Weight, length, these are the numbers. The number represents something there, right? And the categorical has two categories. No problem. One is qualitative. Qualitative means that these are the categories, and these are the different. The word have some meaning. It doesn't have a quantity. It's not associated with the quantity. It has something related to quality. So, like for example, ethnicities, disease, the gender, and so many other things, right? The nationality. These are the categorical. You can't put them into order. So they are categorical values. And another categorical values are ordinal. So there are some, yeah.
Now I know why.
Thanks, no problem. Thank you. All right, so we have two different kind of variable. The numerical, which is quantitative, which can be a continuous number or discrete number like integers, and categorical, where we have qualitative and ordinal. So qualitative means the names, like for the ethnicity, disease, and ordinal are also categorical, but you can put them into order. So there's a small difference between these two. So these are the category which you can't put them into order because there is no relationship of which is greater and which is less. But in ordinal, yes, you can put them into order. They are category, but you can put them into order. For example, rating of a product. So everybody rate 1 star, 2 star, 3 star. They are categorical values, but you can put them into order. 3 star is better than 2 star. We know that, right? Age group. We have a group of like 10 to 15, 15 to 20, and these are categorical because they are different category, but you can put them into order, right? So in categorical we have two kind, numerical we have one, and there are different kind of operations that we can perform, and this decides that which kind of statistics you can apply on them. So can we add them, can we subtract them, can we compare them, like this. So let's see, plus, minus, and multiplication, adding, subtracting, and multiplying. Can we do it for quantitative numbers? We can add them, we can multiply them, we can subtract them. What about qualitative? Can you add two ethnicities? Not in a literal sense, right? But you can't, right? What about ordinal numbers? Can you add them? Why not? For example, rating. You rate something as a 5-star, you rate 4-star. Can I add them? So you can, right? Can you subtract them? Yes. Can you multiply with something? Yes, right? I can take average of your rating by just adding them and divide by 2, 4 and 5. So you can, right? What about greater than and less than? For quantitative, can you apply this operation? You can compare two numbers if they are greater or less. Qualitative, can you compare two ethnicities if which one is greater, which one is less? No, right? You can't, because and what about the disease or sex or nationality? You can't compare them. So this operation is not valid for the qualitative. What about ordinal? Can you compare them, which is greater, which is less? Because the word says ordinal means you can put them into order, and order means something is good, something is higher and something is smaller. What about the equal to and not equal to? For quantitative? For qualitatives? We can't compare that both two things are same or not. I can compare your nationality and your nationality, if that's equal or not, right? I can compare if some two people have a disease or not, right? I can compare their ethnicity, their gender. So I can compare if two categories are same or not, exactly same or not. So this operation you can do for the qualitative. What about ordinal? Can we compare them if they are equal or not? Right? So these operation will decide what kind of statistics you can apply, or what kind of averaging, or what kind of operation you can apply, right? And in between, if you have any question, doubt, or if I'm saying something wrong, which I might say, just raise your hand and say. Even if you don't have to raise your hand, just ask question, right? All right. So visualization. So there is the one impression of the data. So now you have this sale, the profit of a company per month, and there are two people looking into the same table and concluding different thing. One is saying on the left that profit is very steady, right? It's not, there is nothing special about it. But on the right, this guy is saying, oh, profit is going very high. It's very good. It's increasing. What do you think? What's wrong? They both are looking into the same data. One is saying something else, another is saying something else. What do you think? What's wrong in here? Okay, who's right? Left or right? Is she right? Is the profit steady? You can see the data, right? That's a month and that's a profit in millions, right? 2 million, 2.1, 2.2, 2.1.
I think in the beginning it was steady, but then it stopped breaking.
Yeah, so that means she's wrong. And he's saying it's going high. Anybody else wants to contradict? So, okay, let's try to plot this. Because she's looking into that plot in mind, and he's looking into that plot in mind. So according to her, it's steady same, right? And it's the same plot. It's a plot from the same data. What's the difference? The scale, right? That start from 0, and that start from 2. So from here, what exactly you said, this was little steady, but then it's going up. And in fact, you can see like it's going up, right? And according to this, you can't see anything going up. It's okay, it's not much. So who's right and who's wrong? Both are?
It depends of your visualization.
So you say that I can just show any visualization to make up anybody's mind anything? So that means I can write a research paper showing that, oh, my company is growing fast. Or you can write, no, you're not. Who's right? Somebody has to be right, right?
She's the right lady.
She's the right. Why?
Because it starts from 0
Uh-huh.
to the 2.5.
Mm-hmm.
It's the old stuff from shareholders.
Okay.
It starts from nothing, like billion or something, up to 1 what about minus 4? What's the below 2?
Mm-hmm.
Something has to be below 2, right?
Okay.
The price should drop to below 2.
Yeah.
He's persuading his bosses.
So you are saying that he's just pursuing the bosses that yeah, it's going up. So you are right that because this is 0, you have to compare from 0. But do you always have to compare from 0? Maybe the companies start with 2, right? Or maybe companies start from 1. And this is a million we are talking about. So million from 2 to 2.4 million in 6 months is not bad, right? So the point is that both are right and both can be wrong also. It depends on the context. So we can't say that who is right and who is wrong. It's all about the context. How much amount of the difference it matters. Does this matter in the company? Like 0.4 million, is it a big number or is it a small number? Maybe for the big company it's not, right? So it's all about the context. But visualization is helping you to prove your point, right? And according to her, it's not that big a deal because it's not a small change. From his point of view, it is a bigger deal, right? So you can put your point with the figure, but it depends on the context. For example, if you are talking about the blood pressure, right? If you are testing the blood pressure of a person, and it changes only, let's say, 180 to 185, a little bit, right? I'm not sure how good numbers are, but 180 to 85. One person say, oh, it's a big change, and another says not. Same thing, same story, right? Now it depends on your context of the story and the study that you are talking about. Is it a big number or not? It's up to you, right? They can't tell you which is right or not. So important thing is that visualization helps a lot. We will see all these things in a lab session, how to plot them. So every time you see that orange dot there in the slide, that means this is something that we will come back on the lab session or the next session, right? How to plot, which plot to use and when to use, which makes sense or which doesn't. All right. So now let's go to the descriptive statistics. So what is average, frequency distribution, and spread, skewness. The basic theory you all know, but we'll talk about which to use, why to use, and when they can fail, right? So for example, this is a height of a class in a person. Can you calculate, okay, just to clarify, mean is a sum of all the number divided by the total number, right? Median is, you put them into order, take a middle value. Mode is the most frequent value, right? I hope everybody know that, how to calculate. Okay, this is the height of a people in the class. It's in feet, not the centimeter. So can we calculate mean of this? Can we calculate median? Can we calculate mode? Will mode make sense? Okay, will mean make sense? Median? Mode, will it make sense? Depends, right? If values are 4.01, 4.02 and none of them is matching to anybody, then your mode is not going to make sense because every value is slightly different from each other. They are not exactly the same. So again, it depends, right? Preference of drink. Let's say I ask everybody in the class, what do you like? And somebody said tea, coffee, tea, milk, tea, coffee. Can we calculate mean? So by the way, this is a categorical data. This is numerical data, quantitative, right? Oh, yeah. So can you calculate mean? Because you can't add them. Can you calculate median? Can you calculate mode?
Yes.
Age group. So I ask people that just rate your age group. Click on your age group. 3 people are 10 to 15, 1 is 15 to 20, and then 3 are 20 to 25, right? Can we calculate mean? No? Can we? But this is ordinal. Ordinal, that means there is a meaning, there is a sense that this is smaller than this and this is greater than this. Can we add them? Okay. So, okay, let's go to the question why we want to calculate mean. to find the center tendency of the data, right? That's the full term for the average is the center tendency of the data. What is the more likely values, or where the data is tending to? What is the center of that? So mean, mode makes sense here, median makes sense here. Here mean doesn't make sense, but still you can say, okay, on the average people drink tea because tea is higher. We are using the same number, same words. On the average people drink tea. On the average people are 4, right? And here what would you say? On the average people are, like if one of the categories was higher, you can calculate mode here easily. Mean and median, technically yes you can, but the question is, will that make sense to your study or not? So for example, 10 to 15 I have 3 numbers, 15 to 20 I have 1, and 20 to 25 I have 3. I consider, okay, let's say take the middle value of this 10 to 15, which is 12.5, 12.5, 12.5, 12.5, 15 to 20, 17.5, and 20 to 25 is 22.5 as a middle value, as a value. Add them, divide by number of values, I got the mean. Is it a true mean? No. Does it still make sense? It might, depend on again the context, right? But the question is, here you can't apply the mean and mode. Here you can, but the question is whether that will make sense to you or not. Just think about the rating here, rating of the product. That is categorical, that is ordinal. Can we take a mean? Amazon always does it, right? They always show you the average rating of a product. That's 3.5 or 3.7. After 100 or 200 or 1000 people, they rate them, right? They are doing the mean of a categorical value because they can, right? So the question is, will that make sense to you or not, right? Okay, let's try to understand where it can go fail, it can go wrong, right? So we will have one example where there's a London Health Club, and they are proud to have a class for everybody, right? And they use a little bit of statistics to make that sure that everybody have a class that they want. How they do it? They calculate the mean age of every class and put it there. So class 1 has mean age 17, 25 and 38. Whenever somebody comes, they ask them their age and check which is the closest one, and they put them in there, and they think that, okay, that's fine. That's how we actually make sure that everybody go to the right class of people with their same age. So there's a new person who's in 50s, and where would you put him? Class 1, 2 and 3. 3, right? Because it's closest. Do you think it's going to be fine, or can anything go wrong? What can go wrong?
For example, everyone has the 38 age.
That's fine, right? If everybody has 38, he is still closest. Compared to the other two, he is still best fit there, right? So that's fine.
But there's a possibility that majority of the class on the class 3 is maybe for example 10 years old, and but there are few people in their 50 or 40, so the average will be 38.
Yeah. So average has one of the problem that a big number make a big difference there. And he ended up in a class where there are a lot of teens and only few Kung Fu masters. So average is pulled to 38, even though everybody was around like small values, right? 19 or 18. So average fails here, right? What do you do? What do you think? What we can do? Let's see that how the distribution looks like. The distribution looks like actually this. So there are 319, 620, 21, 3, and there are 2. It's a hypothetical edge, of course, just to make a point. But these are the Kung Fu masters, and let's assume that they can live by that. So he ended up in a class because the average is somewhere here, mean, which is right. So what should class do? What should club do to fix this kind of problem? Standard deviation. Okay, why not median? What? median. Median will fix the problem of these big numbers. So what is median? You put them into order and check the center value, right? Now the center value makes sure that the 50% of values are here and 50% values are on this side. No matter how big this number is, center will be this still. This can be 1000 and this can be 2000. Center value will be still this, right? Yes?
But wouldn't it be the same problem for like 19, 20, 21, 38, and then 60, 61? The middle still comes 38.
Yeah, so if they are almost equal.
But it's not a true representation like standard deviation.
Standard deviation is not a representation of the center tendency. The standard deviation is representation of the spread, right? But that kind of a question will come back, but you are saying if this is 60, 60, 65 and this is 20, 20, 25, right? Still the middle value come like this. That's one of the thing, it can definitely happen. But if this is even happening, half of the values, half of the people are as old or even older than this guy and half are less older, right? So he's still in between. He's not completely out of the place in the class, right? But in this case, median can save your day, right? So you know now when mean can fail. Mean is very sensitive to the high values. If the value is very, very high, mean is going to pull that. And in fact, that's how we actually put the distribution. So these tail, if you look at into the distribution, this is a very one high values. There are few high values and a lot of values are here, and these small high values are like skewing it up. So mean ideally should be here, but it will be a little bit here because the high values is pulling them there, and here it will pull them this side. We call this kind of distribution as the skewed distribution, right skewed or left skewed, or positive skewed or left negative skewed. Okay, so they learn, health club learned something, and they say, okay, we won't just go for the mean, we'll also go for the median. They advertise that, okay, we have a swimming club which has a median age is 17, right? And they also check, okay, mean and median is 17, right? They advertise anybody who wants to join, and there's a teenager who say, oh, that's teenagers class, sign me up, right? And what do you think? What can anything go wrong? Class which has mean and median 17. He's a teenager. He just joined the class. Is anything there that can go wrong? Right now it doesn't look like, right? It looks like, what can go wrong? Mean and median, both are 17. It should be fine. Turns out, yes, it can go wrong. So there are very few like this side, very few this side. And mean and median is exactly in the between, which you were just saying, right? If everybody is small and high, median will be this, right? Turns out this class was designed for parents to bring their kids for swimming teaching, right? And every parents above 30 was bringing their kids who was below 4, right? So, and mean and median was still 17. So this person is still in the out of the place, right? What should we do? Well, that's less obvious now because that's the last thing we are left with, right? Mode. So mode is going to save you the day. So here you can see there are two modes, and we call this kind of a thing as a bimodal because there are two modes, right? So you can find out the mode of the data and then say, oh, it's not the center tendency. So mean, median can also fail, right? Okay. So normally distribution looks like this, and we always look at this kind of a curve, which is called the normal shape or bell curve or normally distributed data. We like it very, very much because it has some good property. It helps us to deduce a lot of things. And also coincidentally, world is going around like this. Like, so if I take a height of everybody in a class, it will be nicely bell-shaped curve. If I take the marks of everybody, we have nice shape that some people are just mid-average, very few are very good, very few are very poor, something like that. So this is the how we look into world like this. It's not necessarily world is like this, but that's how we are trying to fit the world like. where it's a normally distributed, centered and like exactly at the center. We have mean, mode, median exactly at the center, and it's completely symmetric, right? This is positive skew, where there are few values which are very, very high, and that's why your mean is shifted from here to here. Mode is of course where the highest value are, but median is in between. Similarly, if you go here, the very few values are very small, that pulls the mean this side, and then you have mode, median, little difference. So this is negative skewed, right? So ideally we want everything like this, but practically we find this in this situation all the time, right? So now you know when mean, mode, median can fail, and what to use and what not to use, right? Let's see the spread of or the variability. So why we like this Gaussian curve or this normally distributed data? Because it has a nice property, as I said, right? So if you have a nice normal distribution, what happens that, and if you calculate the standard deviation, which is sigma here, so from mean to one standard deviation here and here, you have almost 68% of the data. Two standard deviation, almost 90% of the data, 95% of the data, right? Three, it's 99% of the data is there, right? That's a property that we count on in statistics a lot, right? We want to always be like counting that where is the 99% of the data is, where is the 95% of data from mean, right? So this standard deviation can tell you the spread, and if it is normally distributed, then you know from mean, if you go to standard deviation from plus and minus, you cover almost 95% of the data, right? So 95% of the data lies there. Now this is one example. So if you look at the blue one, has a standard deviation 1, orange one has 0.5, and green one has 0.3. So the smaller the standard deviation is, the narrow it is. The higher the smaller standard deviation is, the wider it is, right? It is widely spread then, right? So these are the two things that we calculate: standard deviation. Variance is just a square of standard deviation. Range is another thing that you can calculate to see the spread, minimum, like maximum minus minimum. And interquartile range is another thing that we check, which is a middle 50%. So this is a middle 68%. Interquartile range makes sure that there is a middle 50% values. That's the interquartile range, right? And then there is a percentile. So there are a few other things also. But to understand what's the meaning of spread, let's see a question here. So let's assume that you are a coach of a football team or a cricket team, and you want to hire a new player, right? There are two players comes for the interview. Both of them have the mean score is 4. One has a standard deviation 4 and another has a standard deviation 2. Which one will you hire? Which one? Player 1. Player 1 has a mean of 4 and standard deviation is 4. And player 2 has a mean as 4 and standard deviation 2. Don't look at the picture and hire them, like. Don't see which one looks cooler, right? Which one you will hire? First one. Why? The standard deviation is close to mean, that's why. But what a standard deviation says? Mean says where is a, okay. Mean is this middle value. A standard deviation is this. This length is a standard deviation. And this is a mean. So if we even go back, this is a mean. And spread here and there will be the standard deviation. Okay? So standard deviation tells you how far you can go from mean, right? So it is equal or not doesn't make sense. So player 2, why? Consistent. Why would you say consistent? Because standard deviation is narrow. That's mean, in a rough sense, you will say like this. 4 is a mean score, and standard deviation 4 means that player can score to 8 or 0, 68% of time, right? 95% of time, 2 standard deviation. You can't score negative marks, but negative score, but you can go up to 12, right? That's a 90% of time. 95%, like if you go that, it will do, right? But 60% time he will do this, right? This, he will do 60% of the time, he will just go 6 or 2. He's more consistent, right? 95% time, he will still score up to 0 to 8, right? So he's more consistent, right? So the idea of a spread is that you like a smaller spread because it tells you how good is me, how much you can rely on me, right? So two people can have the same mean, and different standard deviation will tell you that how likely you get this, how often you get this. One company has the same average profit, another company has same average profit, and their standard deviation in last 20 years must be very, very different, and you will say who's consistent, right? So that's the meaning of spread. That's how we actually calculate the spread. So out of the mean and spread, mean and average and spread, we have one nice plot that can show almost everything about the data, which is called the box and whisker plot. So box and whisker plot, because we have a box and we have two lines which is like a whisker, right? When you plot for any data, it tells you almost everything. Why? Because this line in middle line in the box is a median. It says the 50% data is here, 50% data, this median line says the 50% data is in this side and 50% is this side, and in the box 25 is here, 25 is here. So this box covers the 50% of data in the center around the median. So you know already this is a median, right? You know this is the data, so you can see almost the 50% of data is actually here, right? 50% values lie here. You can see the minimum and maximum, right? And you can also see the kind of a skewness it has, right? If this is bigger than this, that means it is already skewed, right? Little bit. Look at the middle one. This and this is kind of very similar, right? It's symmetric. So here we have a box in between, median is between, and they're nicely distributed. And this side we have box, and you can see this area is little bigger than this. And this is still covered 25% of the point and this 25% of the point, right? So this box plot almost tells you everything, right? That's a kind of a definition of the points, every point. We call this as quartile 1, quartile 3, and this is a middle quartile, which is a median, and this range is called the interquartile range. From 25% to 75% is the middle 50% range, right? And you can go ahead and put the mean in that also. So let's say that if I have to put the mean of this data in this box, where would I put it? Okay, let's go with this. Where is the mean of this? Exactly at the center, right? So my mean will be here. What about this? Where would be the mean? This here or this? Look for the tails in a distribution. Tails pull the mean. So this side. What about this? This side? This side. This side, right? So yes, you can put the mean as a dot, and it almost tells you everything. It's telling you what's the center tendency, and it's telling you what's the spread. That box plot is something that I love because you can talk about the whole data and alike. Now see the example like this. Working hour of a person or a student in a whole week, right? Now you can say that this person have it's a time slept timing, right? Sleeping timing, yeah, of a student, let's say. So when do you think that that a student sleeps a lot? You can compare them, right? How many hours a student is sleeping? Which day a student is sleeping more? Friday. Why? Because median is higher than anything, right? range is still 12 to 6, right? What about Saturday? Median is little less, but still it is high, right? Which day he is sleeping very less number of hours? Thursday. And there are some points like this. When you plot with the tool, you will find extra points which is kind of outlier, which is like sometime happen which is very out of the range. So maybe after all the years or all the days that we calculated, one day he slept only for 3 hours on Thursday, and for on Friday maybe all night partying, he didn't sleep at all, right? So you might find those outliers, and that's how we actually put it in the dot. All right, so this is another question, that can we convert any categorical value into continuous, and is it a good question, good to do or not? But that we will again go back in the lab session to discuss. All right.